day. Today we're gonna go over this practice quiz. Hopefully you've gotten a chance to complete some of it. Fill in the blanks using the available answer choices. Asha or Aisha is writing the number 7 and 13 hundredths times 10 to the 5th in standard form. The decimal point should be moved. How many spaces? 5 places to the right. We know that it is 5 because that's the number, and it's to the right because it is positive. The number in standard form is, so if we took our 7.13 and moved it 5 decimal places to the right, 1, 2, 3, 4, 5. How many zeros do I need to add? 3. So we should have 713,000. Is that a choice? Yes. All right, any questions about number 1?
I got that right.
Hopefully we're okay there. That's all from section 1.5. The population of Michigan was recently recorded as 10,077,331 people. Write an estimation in scientific notation for the population. So we're going to say about how many people. Well, what would we round to? The nearest what? The nearest million or the nearest 10 million? The nearest 10 million, right? So this is 10 million. So how would we write 10 million? 1 times 10 to what? How many place values would there be if we put the decimal here? Count them. 1, 2, 3, 4, 5, 6, 7. So 1 times 10 to the 7th. That is in scientific notation, right? It's got to be a number between 1 and 10, right? So we should only have 1 digit to the left of the decimal point. All right, number 3, a car weighs 4,100 pounds. Is it more appropriate to express the car's weight as 4,100 pounds or 6.56 times 10 to the 4th ounces? Remember, what's most appropriate has the least number of zeros. So pounds or ounces? Pounds. So it's not necessarily the fact that we can't express weights in scientific notation. It's the fact that the number of ounces is unnecessarily large and difficult to comprehend. So choosing the larger unit of measure is more appropriate here. You can use really big numbers expressed in scientific notation, like they did with the number of ounces, but it's harder to wrap our heads around that many ounces as opposed to the number of pounds. All right, the mass of Saturn is about 5 68 hundredths times 10 to the 26 kilograms. When this number is written in standard notation, how many zeros are in the number? Well, how many times do we need to move the decimal point? 26. So when we move it the first 2 times, they're not 0, right? So how many more times are we moving the decimal? So how many zeros are there? 24. Excellent. Does that reasoning make sense to you? Any questions with numbers 2, 3, or 4 before we move on? We're okay? So far, so good. Yes, you can use this on the quiz. In fact, I hope you do. All right, calculate. Write your answer in scientific notation. So I would probably use my calculator and say 7.5 times 5. That's the first thing I would do in my calculator. And then remember, because we can associate multiplication any way we want to.
27.9.
All right,
You put 7.5 times 5.
because I'm associating them.
Is that?
7.5 times 5 is 37.5. And this would be times 10 to what? When we're multiplying, we add our exponents. So 5 plus 3 is 8. Now I have to move my decimal back a place, right? In order for it to be in scientific notation. So if I move it this way, I have to multiply by another 10 to get it back. So I'm going to say 3.75 times 10 to what power? The 9. That's the tricky part. If you're not sure, watch this. I'm going to say times 10 to the 8th. Remember, I can use this caret here. 10 to the 8th. And it will write it like this. So I can place my 0 here. So the calculator wrote it out. 750 million, and then 1,000. So if it's easier for you to go from here to here and then back to here, do that if you're not sure what to do. And then I put my decimal here and I would count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so one way or the other, you should get 3 75/100 times 10 to the 9. All right, here, remember we can associate these two things and these two things. So 7 divided by 4, 1.75 times 10 to what? What's 7 minus 2? 5, right? And we have a number between 1 and 9, so we can leave it like that. That one's a little easier. Would you agree? I said 7 divided by 4. This. All right, so now they want us to evaluate this. Remember, you can change these so they're both have the same factor of 10. However, my suggestion would be to do what? What did we do? We went to standard, added them back to scientific notation. So if I'm doing that, you can use your calculator for this. 3.12 times 10 to the 5th, right? 312,000. And it says plus 5.3 times 10 to the 4th. This is 53,000. Now I'm simply adding, which you should not need a calculator for, right? 365,000. Can we leave it like that though?
No.
No, pay attention to how they want it. Scientific notation. Where would we put the decimal here? Right here, right? So 3.65, and then we have to count 1, 2, 3, 4, 5. So times 10 to the 5th. Same thing with number 8. I would change them. So 9, 7, 3, and 3 more zeros minus 74 and 3 more zeros. This one you might want to use a calculator for, right? Since we have to do a little borrowing. 899,000, is that what you guys got? Did you do this one yet? Can we leave it as 899,000? No, we have to change it to scientific notation. I'm going all the way to the end here. 8.99 times 10, so we gotta count how many we would need to move it to change it back to that. 1, 2, 3, 4, 5. Fair? I would say it's easier to change to standard and then back to scientific. All right, writing this in standard form. How many places do we move the decimal? 1, 2, and then we need how many more zeros? 2 more, because we're moving it 4 places. Is that standard form? Yes. Writing this in standard form. This we move to the right because it was positive. If it's negative, which way do we move our decimal? To the left. So if I move it over 1 time to the left, how many more times do I need to go? 4 more times. So how many zeros are going to be before my 5? 4. If you need to draw it out, like write it somewhere else, right? 5.7, and then move it 1, 2, 3, 4, 5. It's totally acceptable for you to use scratch paper or space to complete your problem, right? Writing this in scientific notation. Now, right away, we should know, is our exponent going to be positive or negative? Negative. Anders, are you with me? Okay, I'm kind of concerned you're not. Where is my decimal going to go? Right here, right? We have 1.4 times 10. We said it's negative, and we're going to go 1, 2, 3, 4, 5, 6, 7. So pay attention to how they want your answers. Pay attention if you need to go left or right, positive or negative. Questions about page 2? Still so far so good? Excellent. All right, this in standard form. Again, you need some more room. Move it over. Are we going left or right? Left. How many space? Yes, 1. So we're going to have 1, 2, 3 more, which means we have 3 zeros. All right, so if you were reading this, tens, hundreds, thousands, 10,000s, 100,000s, 2,900,000s. All right, where does my decimal go if I'm writing this in scientific notation? After the 8, so I have 8.42. You can pretend to put it here in your number and then simply count. 1, 2, 3, 4, 5, 6, and 7. So times 10 to the positive 7. Don't forget to multiply by 10. I guarantee someone tomorrow will write 8.42 raised to the 7th power. That would not be correct, right? Make sure you're multiplying it by 10 to that power. Are you saying like not me? No. All right. Where would I put the decimal to change it to scientific notation? After the 3. So I'm going to go ahead and write that out. Now I know times 10, is this going to be positive or negative? I would have to move this to the left, so it's going to be negative. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did you get that? All right, putting this in standard form. How many places do we need to move? 4 to the right. So 1, 2, 3, 4. I need to add how many zeros? So I would write 94,000. Make sure your numbers look like what you want them to represent, right? How would I write this in standard form? Again, I'm moving to the right because it's positive, and how many places am I going to the right? 6. 1, 2, 3, 4, 5, 6. Now tomorrow you might think, oh, I've got this down, but don't rush. Draw it out so you don't make silly mistakes. Even I still draw it out so I don't screw it up. I'm gonna move a little bit further down this way because I know I have to move to the left. How do I know that I need to move to the left? The exponent is negative, so I'm gonna go how many places to the left?
5.
1, 2, 3, 4, 5. You got it. 1, 2, 3, 4, 8, 3, 1. So this is 831 tens, hundreds, thousands. 10,000s, 100,000s, millions, 10 millions, 831 10 millions. All right. Now we gotta go think the other way. Where would I put the decimal? Right here. And is my exponent on my 10 going to be positive or negative? Positive, because I would have to move it to the right to change it to this. I would have to move it to the right 1, 2, 3, 4, 5, 6, 7, 8 times. Same thing here, right? Times 10, it's gonna be positive. 1, 2, 3, 4, 5, 6. Right? And last one, remember this is 3.3, so envision it here. I would have to move it to the left to get this final standard number. 1, 2, 3, 4, 5, 6. Okay? Questions, concerns before our quiz tomorrow? All right, you'll have all hour for your quiz. Come with this and your packet. You'll turn these both in tomorrow with your quiz. Have a fantastic Wednesday.